record notes, so I don't know if you even care about that, but just letting you know. Okay, so we've been talking about concavity. Remember, concavity is the second derivative. Okay, so now we're going to tell you what concavity does. Okay, so concavity tells you if the slope is increasing or decreasing. Okay, concavity tells you if the slope is increasing or decreasing. Okay, so remember you can have two types of graphs, concave up or concave down. And so what we're going to do is we're going to split both of those graphs in half, and we're going to talk about them in chunks. So cut this one in half right here, cut this one in half right here. So we're going to draw this side of the up graph. Then we're going to draw, hold on, I have to think about this side of the up graph. So they're like, you took this smiley face and you like cut it in half. Okay? And then we're going to do the same thing for our frowny face. We're going to have this half of the frowny face and then this half of the frowny face. So you have a very weird little chunk on your paper. Okay, so I'm going to do the first one for you. Okay, so we're going to look at three things. We're going to look at the first derivative, the second derivative, and then we're going to talk about how they're related to each other. So this graph is increasing. Yes? Everybody good with that? It's going uphill. So f is increasing. That tells me that f prime of x is greater than 0. Everybody on the same page about that? Okay, if f is increasing, then f prime has to be positive. Okay, now let's talk about concavity. F is concave up. What does that tell us? Not about f prime, but about f double prime. Would have to also be positive. So what you would say is that f is increasing at an increasing rate. Okay, so it's increasing at a rate that's getting steeper and steeper and steeper. Okay? Okay, now let's jump over here to this one. Ready? So what would we say about f for this graph right next to it? What is f doing? Is it increasing? It's decreasing. So f is decreasing. And what does that tell us about f prime? Less than 0. Because remember, f prime tells you about the slope. So if f is decreasing, its slope was negative. Okay, now let's talk about concavity. F is concave down. What does that tell us? That f double prime of x is less than 0. That means that f is decreasing at a decreasing rate. Okay, now for some of you that are thinking about what you're writing, this doesn't make sense because how is it decreasing at a decreasing rate when you can see that it's getting steeper? Okay, I'm going to do my best to explain why that's not the same thing. Yes, okay, but you have to think about, remember, so this is talking about this slope, okay? So if I'm looking at this graph right here, let's say that here my slope is 1, then it goes to 2. Do you see how your slopes are getting steeper? Okay, then 4, maybe that one would be 5. Okay, let's do the same thing on our other graph. I wouldn't write this down, I would just kind of listen so your thing doesn't look crazy. Okay, here my slope would be like -1, right? What would it be here? -2, then -3, then -4, then -5. Okay, technically, the slopes that you just listed to me, even though they're getting steeper, that's not what we're talking about. Is the value getting larger or smaller if you went -1, -2, -3? Does it make sense that they're decreasing? Even though it's getting steeper, that's true. You have to remember that steepness doesn't have a sign. It's kind of like speed. Okay, but if I'm talking about increasing and decreasing, that does have a sign. So if my graph is decreasing at a decreasing rate, that does mean that your graph is getting steeper. Okay, so if you want to put a little star here, the reason that your graph gets steeper is because f prime and f double prime have the same sign. But you would still say that it's decreasing at a decreasing rate because your slopes are getting smaller in value because they're getting more negative each time. Okay? All right, let's go down to the bottom two. Let's do this one first. Is f increasing or decreasing? Decreasing. F is decreasing. Okay, because it's going downhill. What does that tell us about f prime? Less than 0. But what about your concavity? Is it up like a cup or down like a frown? Up like a cup. F is concave up. What does that tell us about f double prime? That it's greater than 0. So here's what you would say. F is decreasing at an increasing rate. And so again, for some of y'all, you're going to have a problem with this statement because that doesn't make sense. It looks like it's getting flatter. That's true, but think about each slope as you go down that curve. What might my slope be here? Maybe -5, then -4, then -3, then -2, then -1. Technically, if you count -5, -4, -3, -2, -1, are those values increasing or decreasing? They're increasing because they're getting less negative each time. Okay? Now, notice what's happening in your graph. It's getting flatter. The reason that it's getting flatter is because your first derivative was negative, but your second derivative was positive. So instead of your slope and your concavity being the same, they're opposites. So we're going to write down here, f is getting flatter because f prime and f double prime have opposite signs. And that's going to be true in the second graph as well, so if you write all the way across, that's fine. Okay, so you fill in the last part. So 3 statements, increasing or decreasing, concavity, and then the long statement at the end. Think about all 3 of those things. Okay, what would I put first? F is what? Increasing. Very good. It's going uphill. That tells me that f prime is positive or greater than 0. But what's your concavity? Okay, concave down. And that tells us f double prime is less than 0. Okay, think about your last statement. If you didn't get to finish writing it, go ahead. Okay, what would we say for that last statement? It's increasing at a decreasing rate. Very good. F is increasing at a decreasing rate. And for the positive slope ones, it kind of makes more sense. It's for the negative ones that it's kind of weird to think about. Okay, but if I were to illustrate this for you, right? You'd have a 5 slope, then a 4, then a 3, then a 2, then a 1. It's easy to see that those are getting smaller because they're positive numbers. Okay? Alright, concavity does one other thing that's sort of important. It tells you where tangent lines are. So if you have a curve, let's draw one that's concave down and then concave up. Okay, draw a graph like that. If I draw a tangent line on my graph where it is concave down, okay, specifically this is my concave down interval. Okay, if I draw any tangent line, where is it going to fall compared to the curve? Is it going to fall above or is it going to fall below? Think about where the line is. It would always be above. Okay, now let's think about for the concave up part. Here's my concave up section. If I draw a tangent line adjacent to a curve that is concave up, where is your tangent line going to fall? Below. So what we're going to put is, if your graph is concave down, your tangent line is above the curve. And then the opposite is true. If it's concave up, your line is going to cut underneath the curve. Okay, so for concave up, your tangent line is below the curve. Okay? So when you're ready, we're going to turn over to the back and we're going to work a first and second derivative test question, but instead of having equations, you're just going to have a table instead. Okay? So turn over to the back. You're welcome. Alright, so look at the top. You have a table. Notice you have x values, f, f prime, and f double prime. Part A says find all the critical numbers for f, then label as a minimum, a maximum, or neither. Explain. Okay, what is the definition of a critical number? Where what happens?
X is equal to 0.
Okay, f prime has to equal 0, or what else could it be? Undefined. So put right here, okay, a critical number is when f prime is 0 or undefined. So when I'm looking at my chart, which row should I make sure I'm looking at? Top, middle, or bottom? The middle, right here. I'm going to look at f prime. Okay, now circle the two places that it is either 0 or undefined on your chart. It's 0 here, and it's 0 here. That means that both of those are critical numbers. Now, where do critical numbers go? Oops, sorry, not 0. What is the value that it happens at 0 at? X equals what? 2. Thank you. 2, and then DNE happens at 4. So from there, I'm going to set up a number line here. I'm going to put 2 and 4 on my number line, and then I want to do a line test, but instead of me having to do all the work of plugging stuff in, I'm just going to look at my chart. Before 2, when it was 0, what was f prime? Don't care about the number, just the sign. It was a positive 4. Between 2 and 4, in the middle, what was the sign? Negative. We don't care about the 1, just the sign. And then after the DNE point, what was it? Positive. Okay, that is the sign of the f prime row. What does that tell us about f? What was it doing? Very good. And so now that we have that, can we label our min and max?
Yes.
Okay, what is 2?
Relative max.
Max. And what is 4? Min. Very good. So you would say at x equals 2, you have a relative max because f prime of x changes from plus to minus. That would be the first part of your answer. Okay, then for the second part of my answer, I would address the 4. I would say that that is a relative minimum because f prime changes from negative to positive. And that would be the second part of your answer. So instead of you having to do all of the work, the table has the information in it and you just have to be able to pull what you need for each question. Okay, part B says, where does f have a point of inflection? What happens at a point of inflection? Okay, the sign of what has to change? F double prime. Very good. So I'm now going to look at this row. Okay, so circle on your table, when does the second derivative equal 0 or undefined? At 3. Before 3, what is the sign? After 3, what is the sign? Positive. So right here, I would put 3 on my number line. This is f double prime that we care about. I started off with negative values, then I switched to positive values. Then will 3 be a point of inflection? Yes. What if it didn't change sign? Then it would not be a point of inflection. Okay? So we would say x equals 3, you have a point of inflection because f double prime changes sign. Now remember, anywhere that the second derivative is 0, okay, that would be a point you would be interested in checking, but it does actually have to switch sign for it to count. Okay, then we have a little bit of throwback questioning about tangent lines. So part C says, write the equation of the tangent line at x equals 1. What two things do we need for a tangent line? Okay, good. Point and slope. When I want the point, all that I know is that x is 1. Where will I go in my table to find the y value? Will I look at the f prime, or the f double prime? F. At 1, what is f? 3. Where will I go to find the slope? The f prime row. At 1, what is f prime? 4. Can I write the equation of the tangent line now? Yes. Now, one thing, I'm going to pass back y'all's quiz on implicit differentiation from a while ago, but some of y'all did this. Okay, you would automatically, instead of putting an x here, you would just write the 1.1 in. Okay, you can't do that because you have two instructions. The first instruction is to write the tangent line. The second instruction is to plug that in. So you want to make sure, write the tangent line, check, then plug that number in. So now we're plugging in 1.1. What is 1.1? Take away 1. Good, this should be familiar. That's a 0.1. Remember that 0.1 bumps your decimal over one place, so instead of a 4, now it's a 0.4. And then what do I do with the minus 3? Okay, plus 3 over to this side. 0.4 plus 3 is 3.4. Okay, so there's now one extra question now that we've talked about concavity that they can ask you. They can ask you if your tangent line, that's your estimation, is greater than or less than the actual value. What answers this question is concavity. So go back up to your chart. Okay, go back up to your chart. At 1, what is f double prime? Okay, let me come back up to my chart. At 1, what is f double prime? Negative. That means my graph is what? Concave? Down. Think about, where would a tangent line be on a frown? Would it cut above the curve or below the curve? Above. Okay, so if I draw a little concave up graph, all of my lines, no matter where I draw it, would cut above that. So you would say it is greater than the curve because f double prime of x is less than 0, so f is concave down. F double prime is less than 0, that means my graph is concave down, and if I have a concave down graph, no matter where I draw my tangent line in, it's going to cut above the actual slope of the curve. Make sense? Questions? No, not really? Okay. So I want you now to switch to your notes packet. We're going to do one more question like that, and then I'm going to have you do a page of your homework, okay? So look, we've already finished one thing, okay? Great job. Okay, so look at your first one. Okay, it says let f be a function that's continuous on the interval from 0 to 3. Says f and its derivatives have the properties in the table. Okay, part A, find the x coordinate of each point where f attains a local max or min. So the first thing we need to do is find our critical numbers. Which row in the table should you be looking at? F what? Not F. F prime. Very good. So look at F prime. Where are the places that it is 0 or undefined?
1.
Okay, at 0, at 1, and 2. So on my number line, I'm going to put 0, 1, and 2. 0, 1, 2. Okay, now, between the beginning of the graph and 1, what is the value of f prime between them? It's negative. Very good. See right here it says negative? Okay, so from 0 to 1, it's negative. What about from 1 to 2? What's the sign? Negative. And then from 2 to 3, what's the sign? Positive. And then I'm noticing that I have too many intervals, so pretend that's not there. No one knows what that is. Okay, we got to label it. What were we looking at? F prime. What does that tell us about F? That it was doing what? Then increasing. So it went down, down, and then up. Okay, well then what is our local maximum or minimum? Where do we have one? At 2, and what type is it? Min. So you would say at x equals 2, you have a relative minimum because what did f prime do that tells us it's a minimum? Good. Changes from negative to positive. Now, if you notice, okay, a lot of times the AP test also uses the word local. Local and relative are the same. Okay? So we have a relative minimum at 2 because f prime changes. Does anything special happen at 1? No. Okay, go down to part B. Actually, we're going to skip part B for right now. Go to part C. Okay, we want to know where f is concave up. What should we be looking at in our table for concavity? F double prime. Very good. So looking at my f double prime row, where do I have an undefined or a 0 in my f double prime row? 0, 1, and 2. Okay? So 0, 1, 2. Okay, from 0 to 1, what is the sign in the middle for the second derivative? Positive, then what? Negative, then negative. So plus, minus, minus. Those are the signs for f double prime. What does that tell us about f?
A concave.
Concave. Up. Down. Down. Very good. Now notice this question asks you to state intervals where it's concave up. Well, then where would we say? From where to where? 0 to 1. Very good. So my graph is concave up. CCU is concave up. Okay, from 0 to 1. Because f double prime of x is greater than 0. Now, it doesn't ask us to find concave down, but we're going to go ahead and do it anyway. So if I asked you where it was concave down, what would you say? 1 to 2 and 2 to 3. Now, if you have adjacent intervals like that, you don't have to separate. So you can just go from 1 to 3. Because f double prime of x is less than 0. You could split it up, but it's unnecessary. Okay? Alright, part D says, where do we have a point of inflection? What would you say? You have to have a sign change, so the only place would be at 1. X equals 1, you have a point of inflection because why?
Changes.
F double prime of x changes sign. And you have to be really careful about not saying things like it changes sign. There's too many things in that table for them to just assume that you meant F double prime. Okay? All right, now let's go back to part B. Part B says state where you have an absolute max or min. So what do we do when we want the absolute? What do we create? Yes, candidates table. Okay, so what goes in our table? Okay, what are my endpoints? Okay, 0 to 3. You can see our interval right here, 0 to 3. And then remember that we also want to check any relative mins or maxes. I only had one. Where did it happen? 2. So these are the only 3 places that I could have a max or a min. Okay, so at 0, what is my y value? What should you be looking at in your table? Okay, F, what is 0's y value? 1. What about at 2? What's my y value? Skip 1. We're skipping to 2. So negative 1. And then what about at 3? Does it give it to us? But we know it's negative. So I'm just going to put negative here. Okay, out of those numbers, which one do we know is the biggest?
0.
Okay, 1 at 0. So we know our absolute max is 1. It happens at x equals 0. Okay, and that's obvious in the table because we know that it is the only positive number. Okay, now for the minimum, it's a little bit trickier, but not much. Okay, think about what did my graph do from 1? It went down, then it went down some more, and then it went up. Which one would have to be smaller, 2 or 3?
Huh?
Okay, one more time, I'm going to ask the question. Listen again. Okay, I go down, down, and then at 2, I start going up. Which one has to be smaller? 2. Does that make sense? Because think about, what did I do between 2 and 3? I went uphill. Well, then I know that 2 had to be smaller. So is negative 1 at x equals 2?
Are we allowed to write negative in the table, in the chart?
Yes, because all we know is that it's a negative value. Now, another hint there would be too, if they didn't tell you what it is, right, then you probably know that's not the answer, or else you'd have to have a way to find it. Okay, the last thing that you have to be able to do is you have to be able to sketch what the original function looks like. So what we're going to do is we're going to take both of these charts and we're going to use them to sketch f. Okay, so first thing that I want you to do is tell me all of the ordered pairs that I know. What should we be looking at in our table if we want y values? Which row? F, F prime, F double prime? F. So what is f of 0? 1. So on my chart, I'm going to put 0, 1. What is the next ordered pair that I'm given, a y value? Okay, x equals 1. What's my y value? 0. Okay, what about at 2? What's the value? Negative 1. And then do we have a y value for 3? We just know it has to be negative. So I'm just going to write that on there to remind myself of that. What you're going to do is you're going to connect those dots in a way that's consistent with your first and second derivative test. Okay, I'll do the first 2 intervals and then you're going to do the last one. From 0 to 1, my graph needs to be decreasing and it needs to be concave up. So if I'm going to connect these dots, I'd have to connect it like that. Think about why. It's going downhill, but it's up like a cup. Okay, from 1 to 2, what 2 criteria does the curve that I draw have to be? It has to be going down and concave down. So if I'm going to do that, I want to go down and I want it like a frown. So it would be like that. Okay, try to draw the last one. Okay, so that one was down and it was concave down. So for my last one, okay, I want to make sure that it needs to be going uphill, but it needs to be concave down. So uphill, but also concave down. So uphill, concave down. And that would be the overall shape of your graph. You wouldn't know exactly what it looks like, but you should be able to sketch it.
Wait, why did we pick F instead of F and then F prime and then F double prime? to plot the points.
So F tells you the points, F prime tells you uphill or downhill, and F double prime tells you how to connect them, like arched up or down. So you really need all three. You just use them at different stages. Okay, so what I want you to do now is get out your homework. Okay, and I want you to try the very first one on the very first page. Your only part of your homework you can do for tonight is the one with the table on it. Okay, the graphs we're going to do tomorrow.
So just the
Okay.
first page of the homework.